So graphing cosine is actually very, very similar to how we did graphing sine yesterday. The main difference is just kind of the way that the graph is positioned. It's not going to start at 0, 0 anymore. If you guys look at the parent graph for this one, there's still some of those key points that we had, but if you guys look at where this graph starts, it actually starts up here at 1. So it's a little bit different. It's basically, it's the same idea as like that sine function, but it's been shifted over a little bit. So at that peak of where our sine function was, which would have been somewhat like a quarter of the way through the cycle, this time that's where cosine starts. So cosine kind of got shifted over, that sine function shifts, and it starts up here at this 1, and then it crosses down again here at 90 at 0. Now 180 goes down 1, so it's at -1, and then we're back up at 270. So we have some of those same key points, and then at 360 you're kind of back up again. So these same points were on my sine function, they were just at different y values. So I still had 30 and 60 and 90 and all those numbers on my sine function, they just had different y values when I looked at the graph. So if we think about, I showed you guys yesterday, like the XY table, like the T-chart that you could use to graph the cosine function or the sine function, you can do the same thing with the cosine function. So this time, if I look at the table, I'm still going to have those points like 0, 90, 180, 270, 360. So it's still kind of along that same period that sine was. So those are the same points that we talked about yesterday. But remember, sine went 0, 1, 0, -1, 0. This one, it starts at 1, then 0, -1, 0, and back up at 1. So the y values are a little bit different because, like I said, this whole graph has kind of shifted over. In order to find everything to graph, it's the exact same as what we did yesterday for sine. So the amplitude's the same, finding the period's the same, finding those 5 key points is the same. In general, this is what all of our cosine functions look like. Just like yesterday, they said a sine of bx. Now it says a cosine of bx. A is still your amplitude, so you're still going to do absolute value of your a. The period is 360 divided by the b. And then 5 key points is taking your period divided by 4, and that tells you how far apart your points are, like how you're spacing them. So same as yesterday, you start at that 0, and then you're going to add whatever that number was to find those key points until you get to 5 of them. And again, it should still end on the number that you found for the period, because it should go from 0 to the end of that for a full cycle of the cosine graph. So let's look at an example here together. So I have y equals 2 times the cosine of 3 theta. So again, this is in that form. A times the cosine of bx. Instead of x, I put in theta. That's just talking about the angle that we're looking at. So amplitude, that's still just the absolute value of your a. So that's going to be absolute value of 2, which is 2. Okay, and make sure you guys know that those are absolute value bars. I had some confusion yesterday, later in the day, where someone thought I was writing 121, because absolute value bars can sometimes look like 1s. So just make sure that you're either making them a little bit longer than your number, because it comes out to just be 2. Next thing we're going to do is find our period. So we're going to take 360 divided by the b. So 360 divided by 3, because that's in the b spot up there in our equation. So that's going to come out to be 120. So that means from 0 to 120 degrees on our graph, that should make a full cycle of this graph for us, of this cosine function. Now let's find those 5 key points. Remember, that's when you take your period that we just found, that 120, and you divide by 4. So that's going to come out to be 30. So all of my points are going to be 30 degrees apart. So I'm going to start at 0, and then count up by 30, So 30, 60, 90, and then 120. Those are going to be my 5 key points. Now, like I said, my y values are a little bit different here because of where cosine starts. So if I'm using this table that I had up here for you guys, for using this, you know, these points here, those are my y values, but my amplitude for this one was a 2. So all of those numbers are going to be multiplied by 2, because that 2 tells us how far up and how far down from the middle of the graph that we go. Okay, so I'm going to go ahead, like in your guys' graph, I'm going to relabel the one that I have in there for you. So where it says 60, I'm going to cross that off and write 30. And then I'm skipping one, I'm going to write 60, skipping one, writing 90, and then that last one is 120. So I'm just relabeling it. You don't necessarily have to. It's just, if you don't, yours is going to be a little bit more squished. I'm just relabeling it so it's a little bit more stretched out. So instead of starting at 0, 0, you have to start at 0, 2. And we're at 2 because that's my amplitude. My first point's going to be up here. Then at 30, we're back down at 0. At 60, we go down 2. At 90, we're back up at 0. And then at 120, we're back up at 2. So in this case, you really have to still be thinking about like that curved nature to these sine and cosine functions. I know that our natural tendency is to want to just draw straight lines and almost create like a V shape here, but that would be an absolute value graph. This is not an absolute value graph. This is a cosine function. So it would continue to kind of follow that trend. So I'm still going to show that it's going to continue to go in both directions. So I'm drawing arrows still on both sides, and eventually it's going to have to go back down, off to the left, and back down, off to the right. If that cosine kept going, it would continue to make that up and down, just like sine did yesterday. It just looks a little bit different from what we did because of where we have to start these graphs at. We're not starting at 0, 0 anymore. Okay, so if you guys turn the page over, I want you guys to try this one. Okay, write out all those things. Write out the amplitude, the period, the 5 key points, and go ahead and try to graph it. Okay, so for this one, your amplitude is just a 1 because there's no written number in front of cosine, which means that it's just a 1. The period, you have to take 360 divided by a fourth, which is the same thing as taking 360 times 4. Okay, because we've got that x over, or like our theta over 4. So that's that fraction. So that comes out to be 1440. So that's going to be our whole cycle for this graph. And then 5 key points, I take that 1440 divided by 4. So the interval is 360 degrees. So I start at 0, and I go up 360 at a time until I get to that 1440. So now I'm going to go ahead and graph. And I think the graph that I have works because it's got all those numbers that I have written out for my 5 key points. I'm not going to relabel this one like I did that last one. Okay, and there's really no, like that amplitude isn't really stretching it at all. It's going to keep it at all those ones. So we start at 0, 1. Then at 360, we're down on the axis. So we're back at 0. Now at 720, you have to go down to -1. At 1080, you're back up at 0. And then at 1440, you're back up at 1. And then we're going to go ahead and draw this in. Okay, and so that's what that graph should look like.